compound. So far what we've had is a metal cation and a nonmetal anion. And what's actually happening in the ionic compounds, remember, one electron is leaving the cation, it's going to the anion, and there's an actual transfer of electrons from one thing to another. When you have that transfer of electrons from one component to another, you end up with a positive charge and a negative charge. Opposites attract, they stick together. Now with these next type of compounds, we don't have any of that happening. There's no more charges, there's no more oxidation numbers, because all that's happening here is we have something called a covalent bond, and those covalent bonds actually just go through and they share electrons between atoms of different elements. There we go, sorry, it wouldn't go to the next slide. So when you share the electrons, like for example here we have oxygen, and it's forming a bond with hydrogen. But when it forms that bond with oxygen and hydrogen, oxygen has 6 valence electrons all by itself. Hydrogen has 1 valence electron. Hydrogen needs 2 electrons in order to make a full octet. Oxygen needs 8. So what happens is oxygen bumps into this hydrogen. And they have this little conversation. Okay, they don't really talk. They don't have emotions or anything like that, but it's fun to say. I probably just got in trouble with the chemistry world for that, but that's okay. So they have this conversation. They say, hey, I need an electron. And they say, hey, I need an electron. And so they come to a mutual agreement that they're going to share these electrons right here and right here in order to get a full octet. When oxygen does this with 2 hydrogens, it ends up with 1, 2, 3, 4, 5, 6, 7, 8 electrons. Hydrogen has 2, which is a full octet for hydrogen, and this hydrogen has 2, which is a full octet. So because they're sharing electrons in order to make their full octets, everybody becomes stable and it doesn't have to bond anymore. So there's no transfer of electrons, they're just sharing electrons. So that's why there's no more oxidation numbers, because you're not losing electrons and transferring over to another one. Now with your covalent bonds, you have 2 nonmetals or more, but usually when we do our nomenclature, you're only going to see 2. 2 nonmetals coming together to make that compound. So maybe you have sulfur and oxygen, or fluorine and chlorine, or iodine and nitrogen, or hydrogen, remember hydrogen is a nonmetal, and chlorine, or I don't know, nitrogen and sulfur. So you can have 2 nonmetals that are different, but then also you can have 2 nonmetals that are the same, like N2, O2. Ozone is O3, so that's just made up of oxygen, but because oxygen is a nonmetal, it would make a covalent bond. So as long as you only have nonmetals in your formula, it is considered to be a covalent bond. Well, this does not want to move. There we go. So in your ionic compounds, you had a metal and a nonmetal. In your covalent compounds, you have 2 nonmetals. Usually the next question that people ask is, well, what about 2 metals? Can I have 2 metals coming together to make a bond? And that is actually not true. Because of their metallic characteristics, if you put 2 metals together, they will not react. All that they do is they make a mixture. And with that mixture, it's actually a special name called an alloy. So like my ring right here is made out of sterling silver. Sterling silver is not pure silver, it's actually a mixture of different metals that they mix together to make the silver stronger. So with your alloys, it's just a mixture of 2 or more metals together, and they don't chemically react. We'll get to mixture second semester, but for right now we're going to go back to your 2 nonmetals and we're going to look at their naming. I just wanted to kind of throw that out there since everybody asks when we get to this point. So when you have an ionic bond, a metal and a nonmetal, those are called formula units. When you have one covalent bond, these are called molecules. So this little compound right here, caffeine, is only made up of carbon, hydrogen, nitrogen, and oxygen. So this is a caffeine molecule. But if you have table salt, NaCl, that table salt, NaCl, is a metal and a nonmetal, that's called a formula unit. So you're going to see that different designation as we're going through the next few units with molecules versus formula units. That's the only difference, is a molecule's covalent and ionic bond is called a formula unit. Now, there are kind of two categories of covalent bonds. The first one you're going to see most frequently, and these are called diatomic elements. Di means two, atomic means atoms. So this is a two-atom element, basically. And all that means is you have the element, and it says it bonds to itself. That probably isn't the best wording. I probably should have changed that. But what it means is you have just oxygen in a sample. And all of those oxygen want to have a full octet. So it's going to take an oxygen, and they're going to make a bond together. Or if you just have a sample of nitrogen, you're going to take a nitrogen, you're going to make a bond together. The same thing happens with hydrogen. So diatomic just means that because there's nothing else available, it's going to bond with an atom like itself. Technically, they're called diatomic elements. Typically, I say, like, don't forget your Brinkelhoff, or don't forget Brinkelhoff as you're doing these. Brinkelhoff is just the element symbols all put together in a made-up word. So it's BRINCLHOF. So bromine, iodine, nitrogen, chlorine, hydrogen, oxygen, fluorine. And with these diatomic elements, when they only have themselves to bond with, they make a covalent bond. This little diagram down here, some people like to remember it this way instead of Brinkelhoff, but you have nitrogen, oxygen, fluorine, chlorine, bromine, iodine. That makes a number 7, but that's only 6 elements, so one more is hydrogen. So I don't know if that's helpful or not, but they are all found right here on the periodic table with your Brinkelhoff, and then hydrogen is one as well. Now with your naming rules, since this unit is all about nomenclature, oh, I got a little bit ahead of myself. So when you write them, when you write their formulas, it's just going to say bromine, or it's just going to say nitrogen, or it's just going to say oxygen. And this is when it is not in a different compound. So if you have, I don't know, sodium and chlorine, this does not apply. But if you only have chlorine present, this is when you're going to use your diatomic elements, and you would write chlorine as Cl2. You would write hydrogen as H2. Oxygen is O2. So again, when it's all by itself, go ahead and it will make that covalent bond. Now with their naming rules, they're actually pretty easy because they don't get a special name. They just get named like their element. N2 is called nitrogen. O2 is called oxygen. Br2 is called bromine. So there's no actual special rules when we look at these. The only thing that you need to remember is when it's all by itself, you put a 2. So for example, this one, this hydrogen, if it says hydrogen and there's nothing else that's bonded to it, we would write this out as capital H2. So this is just called H2. Now if you see something and it just says Br2, when we look at the naming rules, it's just called bromine. Nothing special you have to do here. And then iodine, the formula for iodine or the symbol for iodine is I, so you just have iodine, it's I2. Now, we're going to switch gears and we're going to look at the other type. And this is when you have two different types of nonmetals coming together. And how we name the compounds with two different nonmetals coming together, we're going to use prefixes. Prefixes go in front of a name, and with those prefixes, they stand for a number. So mono means 1, di means 2, tri means 3, tetra is 4. So mono, like the illness, is single little bacteria that float around in your body, as opposed to strep, which is a long chain. Di means 2, like we were just talking about diatomic elements. A triangle has 3 points or 3 sides, so tri means 3. Tetra is 4, like the game Tetris has 4 blocks you spin in 4 different directions to clear out your lines. That's actually where that comes from. Tetra's 4. Penta is 5. Pentagram or pentagon has 5 points or 5 sides. Hexagon has 6 sides, so hexa is 6. Hepta, people always forget. Hepta, people try to put septa, like September. It's actually a different language than this one. For the root here, for your prefix, hepta is 7. Octa, like an octopus or an octagon, is 8. Nona, people can never remember because you don't really ever see like 9-sided objects in geometry, but nona is 9. And then deca is 10, like a decagon has 10 sides, or a decade has 10 years. So mono, di, tri, tetra, penta, hexa, hepta, octa, nona, deca. So these are in order 1 through 10. And with these prefixes, they get added onto covalent compounds only. So if you have a metal, you're not going to use these prefixes. And you're going to use the prefixes with these other rules in order to name these compounds. So the first rule is just like your ionic compounds. Your first element name stays the same. So if you have oxygen and sulfur, the oxygen stays the same. Your second element, you're going to change it to end with IDE. So sulfur would become sulfide. If you have phosphorus and oxygen written in that order, phosphorus would stay the same, oxygen would change to oxide. So first element name stays the same. Second one, you're going to change to end with IDE. The second rule is you use those prefixes, mono, di, tri, all of those, to tell how many of the elements are present. Again, there's no charges, there's no swap and drops. All that it says is, hey, we have 1 carbon, we have 2 nitrogen, we have 3 phosphorus. So it just tells you how many are present, and you just write that down, which is where carbon dioxide gets its name. For the dioxide, di means 2, so it's CO2. Now, using that example, if you notice I didn't put mono on that carbon, that's because you can never begin, on that first element, you can never begin a molecule with mono. You could put di, tri, penta, hexa, anything except 1 on that first element. And that's because that element is implied, and so they just get rid of that mono. So that's why it's called carbon dioxide, 1 carbon, 2 oxygen. Carbon monoxide, 1 carbon, 1 oxygen. So kind of putting all that together, when we write them out, we're going to, again, just say how many are there. It doesn't get reduced or anything like that. But to put it all together, I've got some examples. I'm actually going to swap over to my document camera just so you can actually see me doing the examples. So I have a list here of, they're all covalent compounds, but if you look at your first element, you would need to figure out, is it a metal or a nonmetal? Because it has a nonmetal first, I'm going to use these covalent rules. So I'm going to use prefixes, because this is a nonmetal and that's a nonmetal, to tell me how many of each one are present. So I have 5 carbon. 5 is penta, carbon. First element name stays the same. I have 7 hydrogen, so hepta, hydride. So this is called pentacarbon heptahydride. They sound weird. That is okay. It's totally normal to get really weird names with these. But you just have your rules that you need to learn and use. I'm switching pens, sorry, so you can read it a little bit easier. And just drop those in front. Even though they look funny, it is okay. NO. Nitrogen, there's only 1 of them. With my 1 nitrogen, I cannot put mono on my first element, so I just put nitrogen. But I have 1 oxygen. 1 is mono, and then my oxygen changes to oxide. Now I would have 2 O's here, like that. So mono-oxide, technically, that O, the second one, disappears. They kind of combine together. If you wrote it with the 2 O's, I'm okay with that. I'm not going to mark you wrong. However, I'm going to write it correctly. So if you ever see that monoxide, just know it's mono-oxide. You might see this too with, I'll write it up here, tri, and then iodide. So normally you would have 2 I's there. One of them gets absorbed in, so it's tri-iodide. But when people see that, they're like, oh, tri? What is that? And they're trying to figure that one out. Just know that the 2 I's get combined together. So tri-iodide, like I said, the same thing happens. Br2, there's nothing there except bromine. There's 2 of them, so that's a diatomic element, Brinkelhoff. So this is just called bromine. This one, PO4. Now this might look similar if you're starting to pick up on your polyatomic ions or It's actually one of them that you're supposed to know. And you know that phosphate is PO4 -3. There's no charge on this one though. So with no charge on this one, that means that it's a covalent compound. I have 1 phosphorus. So I'm just going to write out phosphorus. I have 4 oxygen, so it's tetra oxide. Now the next one I give you the name, so we need the formula. Again, these just say how many are present. So di means 2, mono means 1. So I have 2 fluorine, and how we write that is F2. Mono is 1, sulfide is sulfur, so F2S. This one just says fluorine. There's nothing else there. On the periodic table, it says that it's F. However, fluorine is in Brinkelhoff. It's the end letter there. So that means that it gets a 2. It's diatomic. In comparison, if it just said, like, I don't know, magnesium in a compound, or not in a compound, in a reaction, if it just says magnesium, that's just Mg. That's just the element symbol. However, because fluorine is in Brinkelhoff, it automatically gets a 2. Carbon dioxide. I was using this one as an example earlier. Carbon is C, di is 2, oxide, so CO2. So I hope that that's helpful with your covalent compounds. The big thing to remember, big mistakes that people make, is this is only when you have 2 or more nonmetals together. If you have a metal or if you have a polyatomic ion, you do not use prefixes. If you Google things, I'm getting answers that are Googled on your ionic compounds, and people are starting to use organic compounds and organic nomenclature. Unless you're in college, you're not using those rules. So you have to make sure that you're really looking at these things, and you're really looking to make sure that you have 2 nonmetals and you use your prefixes. If you have a metal or polyatomic ions, no prefixes. I hope this is helpful. If you guys have any questions, make sure that you definitely ask.